Let's look again at graphing trig functions. I mean, we did a little bit of it last year, but the units we used for the angular measure was degrees. Now we're going to use radians, but we're also going to vary the shape of the graph as well. So start with the basic one, our sine curve. Of course, we know the basic one has an amplitude of 1, so I'll mark 1 off. Then I'll mark off every 90 degrees, but notice I'm labelling using radians rather than degrees. So I've just labelled every pi, even though I've marked off every pi onto. Okay, our sine curve, of course, starts at the origin. Then we know it goes up to the amplitude, and then it's up and down, all the way there. And there we go, put all those points in. And of course, it's not a zigzag, but it's a lovely smooth curve as such. So there's our basic sine curve. And the sorts of things we're interested in. Domain is all real x, of course. The range is from -1 to 1. Period. The period of a trig curve is how long it takes until you're back to where you started from. But you have to be travelling in the same direction. So if I was down here at the x-axis, I don't say, oh, well, it only took me pi to get back to naught again. The first time I was travelling down, the next time I was travelling up. So it's the next time when I'm travelling down. So it does take 2 pi to get back to that point. And any other point on the curve, it would take 2 pi. So that's what we call the period. And of course, the amplitude is how far high it goes from the axis. So in this case, it's 1. So our general trig curve, we could say is a sine bx plus c, because we could have some sort of shift happening. The period will always be 2 pi divided by the coefficient of x. So whatever b is. The amplitude will always be the coefficient of the trig function. So a sine bx plus c, the amplitude is a. When I'm marking off my divisions, I'll always mark off whatever the period is divided by 4, because there's those 4 key points in every period. You've got when you're at the top of the amplitude, the bottom of the amplitude, and when you're on the axis. So basically you can break it up into 4 sections. So whatever the period is divided by 4, that's what I'll label the axis, which means basically if I'm only drawing one trig curve, I could draw the same curve every single time. I just change the scale on the x-axis. The actual shifting, remember when you're shifting, it's when it's grouped with the x. So the shift is not c, it would actually be c divided by b. So c divided by b, in this case to the left, just depends whether it's positive or negative. So if I wanted to draw, here we go, 5 sine 9x minus pi on 2. Okay. The period is 2 pi on 9, the amplitude's 5, so I'll mark positive 5, negative 5. And each of my divisions will be pi on 18. So the period divided by 4. So we've got a shift happening here. It's pi on 18. Oh, that worked out nice. To the right. So let's draw it in. Amplitude 5. Marking off, there we go, pi on 9, 2 pi on 9. Minus pi on 9. Again, I've only marked off every second, but the actual divisions are pi on 18. Now, normally with a sine curve, I would start at the origin. But we have shifted pi on 18 to the right. So I'll start at pi on 18. But other than that, it does like a normal sine curve. It'll go up to the amplitude. And then I know that pattern continues. So up and down, however far I want to draw the graph. Draw it in. And there's our graph. It's basically exactly the same scale as the last one I did. As I say, all I've done is change the axes, the scale on it. So if you have a math aid, you could use that same template each time, just then mark it in. Okay, let's have a look at the cosine. You remember the cosine curve is basically the sine curve shifted. So all those sorts of things, domain and range, they're all going to be the same. Our generalised one, the period again will be 2 pi on b. And the amplitude will be A, mark off the divisions, every period on 4, and the shift will be C on B. So this time we're going to draw, look at this one, negative 4 cos x on 8 plus pi, and then I'm going to add 2 to the whole thing. So we've got a vertical shift as well. Period is 2 pi on B. B in this case is 1/8. So 16 pi is the period. So our amplitude will be 4. So I'm going to mark off my divisions every 4 pi. Now I've shifted 8 pi to the left, 2 up, and as you say, it's flipped or it's upside down. Let's draw in. Okay. I've drawn in a horizontal line there because instead of winding around the x-axis, because we've shifted up 2, it's going to wind around the line y equals 2. And if the amplitude is 4, that means it'll go up to 6, down to -2. And let's mark off each 4 pi. Cosine curve. I would normally start at the amplitude. Now this one has been shifted 8 pi to the left, 2 up, but then it's upside down. So it's going to be down the bottom. So I'll plot it there at -8 pi, -2. We then go up to the axes, and then up and down, like our curve. Whee. Now, I haven't specified a domain to draw this in, but if you're drawing a curve and they say only draw it between 0 and 2 pi, stop at 0 and 2 pi. Don't go past those points. Okay? Let's do tan then. A tan bx plus c. Well, we don't have an amplitude for tan curves. Remember, they go off to infinity, down to -infinity. Period is only pi on the basic one. So when we generalise, it'll be pi divided by b, not 2 pi divided by b. Divisions now will be period divided by 2, because there's only 2 sections for a tan graph. And the shift still will be c on b to the left. Here we go. Y equals E tan pi x minus 2 pi. So the period will be pi divided by pi. Period is 1. Divisions I'll mark off every half. We've shifted 2 to the right. So okay, let's draw it in. Mark off my divisions. There they are. Every half. Normally with a tan curve I would start at the origin. But this one has shifted 2 to the right. And you remember with a tan curve, it goes x-intercept, asymptote. X-intercept, asymptote. So let's draw those in. There's the asymptote, and going back to the left, there you go, that pattern continuing. And now I'll draw in my tan curve. The other thing to remember when you're drawing tan curves, it should go through at 45 degrees, the tan curve. It's not like the cubic. Don't draw it like the cubic where it has a horizontal point of inflection. It has a point of inflection, it's not horizontal though. So you're trying to get it about 45 degrees. So let's repeat those branches. The E out the front, you'll notice, didn't matter for a tan curve because it has no amplitude. I just thought I'd put E there because, yeah, look good. E. All right. 14C.